Hello everyone. Once again welcome to our physics class. Hope you all are fine over there. Children, in the previous session we had discussed about potential energy of a spring. We derived an expression for the potential energy of a spring. Also we discussed about various forms of energy and power. Today we are going to discuss the last concept of this chapter, that is collision. And collision, two types of collisions are there: elastic collision and inelastic collision. And also we are discussing collisions in one dimension as well as two dimension. So be attentive, it's very important derivation, and try to do the derivation along with me. Be ready with your pen and notebook. Okay children, so let's get started with today's session.
Children, so let's continue with our chapter 6, work, energy, power. Today we are going to discuss about collision. So what do you mean by a collision? A collision is an event in which two or more bodies exert forces on each other for a relatively short period of time. Okay, so as you can see in this figure, so here the two gods are colliding with each other, and in this event the first god exerts a force on other and the second god in turn exerts a reaction force on first one. So the two, or not only two bodies, two or more bodies can exert forces on each other but for a relatively short period of time. So such an event is known as collision. In all collisions, the total linear momentum is conserved. So linear momentum is P is equal to mv. So in all types of collisions, linear momentum is conserved. The total impulse on the first object is equal and opposite to that on the second if two bodies collide. So the impulsive force on the first object is equal and opposite to the impulsive force on the second object if two bodies collide. And there are two types of collision, elastic and inelastic collision. So elastic collision is when the initial kinetic energy is equal to the final kinetic energy. That is, in elastic collision, the kinetic energy is conserved. The total kinetic energy before collision will be equal to the total kinetic energy after collision. And in inelastic collision is one when some of the kinetic energy is lost after collision. So in inelastic collision, the total kinetic energy is not conserved. Kinetic energy before collision is not equal to kinetic energy after collision. Some amount of kinetic energy is lost after collision. Completely inelastic collision is when the bodies after collision move together. Okay, for example, a bullet is fired from the gun. That bullet penetrates a wooden block and lies embedded in it. Okay, so that can be a inelastic collision. And after that, if that block with the bullet inside move together, it will be completely inelastic collision. Okay, children. Now, collisions can occur in one dimension. Collisions can also occur in two dimension. So, if the initial velocities and final velocities of both the bodies are along the same straight line, then it is called a one-dimensional collision or head-on collision. So as you can see here on the figure, here the first object with a mass m moves with a velocity v1 and collides with the second object of mass m, which is at rest. The initial velocity of the second object is 0. That means initially this object is at rest. So only first object moves towards this object 2 and then collides with it. After collision, both first and second objects move along the same straight line. Okay, so here the motion of the first object, and after collision the motion of the first and second objects, all are taking place along this line, along the same straight line. So this type of collision is known as one-dimensional collision or head-on collision. Here the initial velocities and the final velocities are along the same straight line. And as I told you, there are two types of collision, elastic and inelastic collision. So what is the peculiarity of elastic collision? An elastic collision is one in which momentum is conserved and also kinetic energy is conserved. As you know, the total linear momentum is conserved in all types of collision, irrespective of elastic or inelastic. So here, elastic collision, momentum is conserved and kinetic energy is also conserved. So what do you mean by this equation? m1v1 plus m2v2 equal to m1v1 dash plus m2v2 dash. See here, m1v1 is initial momentum of first object, m2v2 is initial momentum of second object, and the quantity on LHS means the total momentum of the objects 1 and 2 before collision. Now here m1v1 dash implies momentum of the first object after collision, m2v2 dash implies momentum of second object after collision. So here the m1v1 dash plus m2v2 dash implies the total momentum after collision. So this statement implies the total momentum before collision is equal to total momentum after collision. Now, kinetic energy conservation, it states that half m1v1 square plus half m2v2 square equal to half m1v1 dash square plus half m2v2 dash square. So here the half terms are cancelled because it is a like term. Now half m1v1 square is kinetic energy of the first object, initial kinetic energy. Half m2v2 square is initial kinetic energy of the second object, and half m1v1 dash square is final kinetic energy of first object. Half m2v2 dash square is final kinetic energy of second object. So the quantity on LHS is the total kinetic energy before collision. The quantity on RHS is the total kinetic energy after collision. So the total kinetic energy before collision is equal to total kinetic energy after collision. This is the conservation of kinetic energy. And also here the total energy is conserved. So momentum is conserved, kinetic energy is conserved, and the total energy is also conserved. And also the forces involved during collision are conservative forces. So what are the characteristics of elastic collision? Momentum is conserved, kinetic energy is conserved, total energy is conserved, and also forces involved during collision are conservative forces. Now next type of collision is inelastic collision. So inelastic collision states that it is the one in which initial velocity v1 strikes a ball of mass vm2 initially at rest, and the two balls stick to each other after collision. Here you can see first object moves with a velocity v1 and collides with the second object which is initially at rest. After collision, both first and second object stick to each other and they began to move in the same direction. Okay, so the combined objects, that means 1 and 2, began to move towards the same direction. That means move together along the same straight line. So here the initial velocity and the final velocity are along the same straight line. Again, this is a collision in one dimension, and also it will be an inelastic collision because finally the two objects stick to each other and then began to move together. Okay. So what are the characteristics of inelastic collision? So here the momentum is conserved, because in all type of collision momentum is conserved. Total energy is conserved, but kinetic energy is not conserved, and the forces involved are not conservative. Okay, so these are the characteristics of inelastic collision. Momentum is conserved, total energy is conserved, kinetic energy is not conserved, and the forces involved are not conservative. Okay, and the best example for inelastic collision is mud thrown on a wall, or any collision between macroscopic bodies in everyday life. So all those are examples for inelastic collision. So with this I am concluding my session. Tomorrow we can discuss the elastic collision in one dimension in more detail. So we will meet in the next session. Notes of the topic and YouTube video have been uploaded. Please go through it. Take care all of you. Stay home, stay safe, keep learning. Thank you.